discuss regarding quinine alkaloids, in which we are going to discuss quinine. I am Dr. Devang Pandya from Department of Chemistry, St. Xavier's College, Autonomous, Ahmedabad. Well, this is the structure of common structure of synconidine and quinine. If these are in which if we are going to put hydrogen, it is synconidine, and instead of this, if our substituent group would be methoxy, then it is quinine. So we need to study regarding this quinine. Quinoline alkaloids. These quinine alkaloids, in which cinchona contains around 25 closely related quinoline alkaloids, of which the most important are quinine, quinidine, cinchonine, synconidine. These are the most, and out of 25 close related quinine alkaloids, it will contain mainly 17 cinchona alkaloids. Out of those 17 cinchona alkaloids, the chief alkaloids are as already I've said, quinine, quinidine, cinchonine, and synconidine. The average yield which is going to be obtained from the cinchona bark, the bark of cinchona tree, uh, is about 6 to 7%, of which half is quinine in the yellow bark of the cinchona tree, whereas in the red bark synconidine exists in a greater proportion, where instead of this methoxy group there should be a hydrogen. Cinchona bark is a dried bark of the stem or of the root of Cinchona succirubra pavenatil cloaks, or of C. legrena Howard, of or of C. Classia Weddell. Their hybrid Ramsia pedunculata. These are the botanical name. That is why I am having little problem pronouncing it. It is a family of Ribacea. Cinchona and its alkaloid have been used in the treatment of malaria for many years. The structure of quinine has provided lead to important synthetic anti-malarial drugs such as chloroquine, mefloquine, etc. Quinidine sulfate is the cardiac depressant and is used particularly in inhibit auricular fibrillation, and that is how this alkaloid is such important. Now, as far as quinine out of this alkaloid is concerned, it is a well-known beta anti-malarial drug occurring among the alkaloids of cinchona bark and ramisia. Cinchona bark contains about 30 alkaloids, 20 to 30 alkaloids, 25 to 30 alkaloids, sorry, but its malarial activity is mainly due to quinine, quinidine, cinchonine, and synconidine. Pure quinine and cinchonine were first isolated in 1820 by Pelletier and Cavendish. The isolation of this alkaloid, the bark is stripped and dried in the sun. This is the original peak of cinchona tree bark. This is crushed to a fine powder and then treated with lime and caustic soda solution for several hours, and finally extracted with hot petroleum. The solvent petroleum is drawn off, and petroleum extract is washed with dilute sulfuric acid in a lid-lined vessel provided with a powerful stirrer. The acid aqueous layer while still hot is neutralized and allowed to stand when the neutral sulfate of alkali, that is quinine, cinchonine and cinchonidine crystallize out. The mixture of sulfate of three alkalides is recrystallized when quinine sulfate, having minimum solubility, crystallizes out first, while the sulfate of cinchonine and cinchonidine remains in the mother liquor. The crude quinine sulfate is redissolved in water, decolorized with charcoal, and recrystallized until cinchonidine and cinchonine are reduced to the required percentage. Quinine may be obtained from the sulfate by precipitation with alkali, washing, and drying. This is a systematic extraction process, step by step, moist the way cinchona bark powder with alcoholic calcium hydroxide 20%, add NaOH 5%, keep the mixture for few hours so the alkali can convert silicon alkaloids to free bases. Then after being non-polar in nature, these free bases can be extracted with benzene in uh, Soxhlet extractor. After Soxhlet extractor, after complete extraction, filter benzene extract and add 5% sulfuric acid in it. Shake the mixture in separating funnel. Separate aqueous layer from the benzene layer and discharge benzene layer. Precipitate of quinine are formed. Filter and recrystallize with hot water. You may get a pure crystalline compound. Another isolation technique would be like this one: stripping and drying of the cinchona bar tree. Then after crushing for extraction with hot petroleum, for then after washing with sulfuric acid or any acid, then crystallization, after crystallization recrystallization, then redissolution, then precipitation, and we're going to get the quinine. So that is the isolation technique. As far as property of quinine is concerned, quinine is white crystalline compound. It is antipyretic, analgesic, anti-inflammatory, anti-malarial. This kind of medicinal property it has. Quinine is insoluble in water. It melts at 177 degrees centigrade in anhydrous condition. It is laboratory, has a bitter taste. Quinine, the molecular formula is C20H25 into 2, has a molar mass 324.424 gram per mole. Melting point is 177 degrees centigrade. Generic name is quinine. In the treatment of malaria as well as babesiosis, this compound has been used, and the brand name is qualaquine or chloroquine, or and many other derivatives of quinine are there. These are certain derivatives of quinines, different derivatives of quinine, which is used in a different medicinal for the different medicinal purposes. Now let's begin our discussion with this. Quinine has two parts, which is bridged by a amide linkage. One is 6-methoxyquinine, that is also known as meroquinine or meroquinine, and other part is quininic acid. Meroquinine and quinine will going to give us quinine. So that way these two linkage will going to give us quinine. Other way out, 6-methoxyquinoline will converted into cincoliponic acid, and then after it is liponic acid, and then that combination also going to give us quinine. So that is the way we can understand that quinine alkaloid is made of two chief part, and which are attached by a linkage, and it will going to give us quinine. As far as pelletier is concerned, this quinine, this is the IUPAC nomenclature of the compound, have hydroxyl group as a secondary hydroxyl group, you can see here, through which the linkage of these two part is attached. The other part contain a nitrogen which is tertiary in nature. So two tertiary nitrogens are there. One saturation is there in the alkaloid as well. So the general technique which we have studied in the first lecture you can apply over here to not only identify but quantify the amount of this functional group in it. One O methoxy group is there as well. It's not C methoxy, it's O methoxy. Oh, sorry, C methoxy group is there as well. When this compound contains two tertiary nitrogen atoms, forms quaternary salt with two molecules of methyl iodide, and through which we can identify the presence of these two nitrogen atom. A secondary hydroxyl group forms monoacetate and yielded a ketone on oxidation. Then after we have a methoxy group. This methoxy group liberates one carbon atom as a chloromethane. It liberates one carbon atom as chloromethane on heating with hydrochloric acid. A vinylic group is there as well that adds one molecule of bromine, absorb one molecule of hydrogen in presence of catalyst and forms formic acid on oxidation with potassium permanganate under controlled condition. Well, this is the compound which is 6-methoxyquinoline, and molecular formula is C20H24N2O2. The presence of a quinoline nucleus in quinine was indicated by the fusion with potassium hydroxide. This is regarding the unsaturation test. This is on oxidation, we're going to get the secondary hydroxy group, and on treating with HCl we are going to identify the presence of methoxy group in this compound as well. Well, here the presence of quinoline nucleus in quinine was indicated by the fusion with potassium hydroxide. When we treat it with potassium hydroxide, it yielded 6-methoxyquinoline and 4-methyl quinoline, that is lipidine. So this two is going to be obtained on the fusion with potassium hydroxide. Oxidation of quinine with the chromic acid furnish two products. Treating with chromic acid we are going to get two products, quininic acid and meroquinine. Characterization of these oxidation products lead to the structural elucidation of quinine. This reaction indicates that in order to know the structure of quinine, we must know the structure of quininic acid or meroquinine. When we know the structure of these two, we can elucidate the structure of quinine. Well, characterization of the quininic acid we can obtain from this quininic acid C11H9NO3. Heating quininic acid with hydrochloric acid gives another carboxylic acid, which when heated with soda lime will going to gives us 6-hydroxyquinoline, that is known at that time. Similarly, heating quininic acid with soda lime yielded 6-methoxyquinoline, which formed 6-hydroxyquinoline as well. These two sequences confirm the presence of 6-methoxyquinoline moiety in quininic acid. The position of carboxylic group in quininic acid was confirmed by further oxidation of quininic acid with chromic acid, which yielded pyridine 2,3,4 tricarboxylic acid. Carboxylic group at carbon 2 and 3, here carbon 2 and 3 would have been produced by oxidation of benzene ring, confirming the position of carboxylic group in quininic acid at position 4, carbon 4. The structure of quininic acid was finally confirmed by synthesis starting from p-methoxyaniline by Rube et al. In 1931. Now synthesis of quininic acid by Rube et al. For that we need to take 4-methoxyaniline, which is treated with this ester, which will going to give us it's going to attach with this substituting one of the hydrogen attached with this nitrogen, turning it to the secondary amine. From the primary amine it gives N 4 methoxyphenyl 3 oxobutanamide. So amide linkage is going to be established over here, and then it is treated with H2SO4. So enolization take place, and we're going to get the cyclization of this will going to give us 6 methoxy 4 methyl quinoline 2 all. So alcoholic derivative is going to be obtained, which is further treated with phosphorus oxychloride in presence of PCl5. The chloro derivative substituting the hydroxyl group will going to get 2 chloro 6 methoxy 4 methyl quinoline, which on further treated with acetic acid in presence of aluminium, it will get the substitution of this chlorine and will going to get 6 methoxy 4 methyl quinoline, which on further treated with benzaldehyde in presence of ZnCl2 will going to get this secondary alcohol linkage of this group over here. So unsaturation is going to be obtained over here, and then it is oxidized with KMnO4. The ben this benzoic acid is going to be removed from here, and we're going to get one carboxylic group over this position, fourth position. It is going to gives us 6 methoxyquinoline for carboxylic acid. So this is Rube et al. To get the quininic acid structure. Now structure of meroquinine. Here you can see in meroquinine one unsaturation is there, which you can identify by treating bromination or by doing hydrogenation, catalytic hydrogenation. One carboxylic group is there. On oxidation with a cold acid permanganate, we're going to get 4 carboxymethyl piperidine 3 carboxylic acid. This one cincoliponic acid. This is a secondary nitrogen present into this meroquinine. So this kind of functional group is there in the structure of meroquinine. Characterization of meroquinine. Meroquinine C9H15NO2 was found to have different kind of functional group, which already we have seen in the previous slide. A carboxylic group from monosodium salt we can identify, secondary amino group from nitroso derivative and monobenzyl derivative we can found. It must be remembered that both the nitrogen atoms were found tertiary in nature in the quinoline. A vinyl group present in this meroquine quinine was intact in meroquinine as well. Heating meroquinine with HCl at 250 degree temperature gives 3-ethyl 4-methyl pyridine, which you can see over here. Heating with HCl, it will going to gives us 3-ethyl 4-methyl pyridine. Oxidation of meroquinine with acidified potassium permanganate forms. This is acidified potassium permanganate will going to gives us cincoliponic acid and formic acid. Which cincoliponic acid yields 4-methyl pyridine on heating with sulfuric acid. The formation of pyridine derivative from meroquinine and its oxidation product confirms the presence of 6-membered N nitrogen containing ring in meroquinine and cincoliponic acid as well. Molecular formula of meroquinine correspond to 3 dB, 1 vinyl and 1 carboxylic group accounts for 2 dBs, meaning the heterocyclic ring must account for 1 dBe. Meroquinine is thus a piperidine derivative with substituent at C3 and C4, C3 and C4, and these substituents could be either a carboxylic group or a vinylic group, or carboxylic and propylidine group as propylene group as well. Taking into account its molecular formula and functional group analysis, the structure of meroquinine was confirmed by sequence of reactions. These reactions can be explained by assigning the structure of the compound. The structure of meroquinine is also supported by the synthesis of cincoliponic acid by Hall et al. So it is a Hall et al. In which you can see that the compound racemic cincoliponic acid was dissolved after acetylation with uh, brucine, and form plus form was found identical with the acid obtained by oxidation of meroquinine. So beta chloropropion acetal treated with ammonia will going to give us amino dipropion acetal, which for treated further treated with HCl will going to get this dialdehyde derivative. On cyclization it will gives us aldehyde derivative, which further treated with NH2OH followed by thionyl chloride will going to get the cyano group over here, and it is further treated with this ester and sodium salt will going to get the Michael condensation process. So this unsaturation is removed by this esteric group, which is further treated with barium hydroxide followed by HCl will going to get cincoliponic acid. Meroquine from 3-vinyl quinine. So 3-vinyl quinine on oxidation will going to give us this intermediate, and it's going to gives us meroquine on this. Well, this is a structure of meroquine, equivalent structure of meroquine as well. Meroquinine, sorry. The linkage between quininic acid and meroquinine in quininic acid, meroquinine in quinine. There is no carboxylic group in quinine, but both quininic acid and meroquinine have a carboxylic group, indicating that these two must be connected through their carboxylic carbon atoms. Where here the carboxylic carbon atoms and the two will may be connected, through which we're going to get the linkage. That secondary alcoholic linkage is going to be established between these two. So that linkage is going to be obtained over here. Carboxylic acid, moreover, secondary nitrogen atom over here. Secondary nitrogen atom in meroquinine must have been tertiary in quinine, suggesting that nitrogen atom also must have also been connected to carboxylic carbon atom present in meroquinine. Precursor of meroquinine may therefore be 3-vinyl quinaclidine, which already we have seen in the previous slide, from which we get this meroquinine, which was found true. Oxidation of 3-vinyl quinaclidine with chromic acid gave meroquinine. The position of hydroxyl group in quinine was established by Rube et al. He oxidized quinine under mild condition of quinone, which on treatment with amyl nitrile and hydrochloric acid yielded quininic acid, and an oxime gave meroquinine on hydrolysis. The transformation confirms the presence of COCH moiety in quinine. So that way we can establish the structure of quinine. Now synthesis of quinine. For synthesis of quinine, the condensation of M hydroxybenzaldehyde, which is represented over here as 489, which you can see in this previous slide. 489, that is this one, M hydroxybenzaldehyde with beta amino acetaldehyde dimethyl acetal, that is this one, 4.90, gave 7 hydroxyisoquinoline, that is this one, 7 methox hydroxyquinoline. Pomeranz Fink's condensation process, it is known as, it is a name reaction, that is Pomeranz Fick condensation. The managed reaction of compound 4.91, that is 7 hydroxyisoquinoline on treatment with formaldehyde in methanol containing piperidine gave 7 hydroxy 8 piperidinyl methyl isoquinoline, that is 4.92, this one, which on treatment with potassium hydroxide at 220 degrees centigrade yielded 7 hydroxy 8 methyl isoquinoline, that is 4.93. This compound was related with the platinum hydrogen, reacted with platinum hydrogen, followed by acetylation gave N-acetyl 9-hydroxy 8-methyl 1,2,3,4 tetrahydroisoquinoline, that is 4.94, this one. The later compound on further reduction with Raney nickel or H2 under pressure followed by oxidation with chromic acid gave N-acetyl 7-keto 8-methyl decarbohydroisoquinoline, that is 4.95, is going to be obtained. The compound, which was a mixture of cis and trans isomer, this is a cis and trans isomer at ring junction, was separated through repeating crystallization. The cis isomer on treatment with amyl nitrite in the presence of sodium ethoxide yielded homomeroquinine derivative, that is 4.96, this one, which on reduction gave amine. Hoffman degradation of this amine yielded cis homomeroquinine. The compound cis homomeroquinine on esterification followed by N-benzylation gave this compound 4.99. The condensation of this with ethyl quinate will going to give us this compound ester derivative. In the presence of sodium ethoxide yielded beta keto ester, that is this one, will going to get beta keto ester. The decarboxylation of compound beta keto ester by heating with hydrochloric acid and further base treatment gave quinotoxin. That quinotoxin and resolution through dibenzoyl tartrate gave this plus isomer of this quinotoxin derivative, the crystallization of which through treatment of sodium ethoxybromide followed by NaOH will going to gives us quinine. That quinine The reduction of this quinine with aluminum and ethanol in presence of sodium ethoxide yielded quinine, which was further resolved to give this quinine as well. So this is the synthesis. Now we can see the under UV light a solution of quinine sulfate added to water forms a, a billowing a luminous cloud. So this is the quinine sulfate which is added into water in UV light. It will going to form this kind of cloud that you can see over here. Now uses of quinine and its side effects are given over here. Uses that you know that it is used in treatment of malaria, babesiosis, treatment of malaria during pregnancy, management of malaria in HIV, management of SIVA malarial treatment as well. So these are the treatment. As far as side effects are concerned, headache, ringing in ear, troubling in seeing, sweating is there, chest pain may be, fast heartbeat you may observe, lower quick back pain, blood in urine sometime, deafness, low palates, irregular heartbeat, etc. And as this side effect, sometimes people are doing some uh, we can say self medication, so they need to rethink about this. Without blood test we cannot take quinine or chloroquine uh, for the treatment of malaria. As far as poisoning is concerned, signs and symptoms will have this already. I have briefed in the previous, but it is somewhat more. Diarrhea and vomiting is there. Sometimes maybe reach to coma. Headache is there. Pupil dilated. Mental confusion. It may produce some hypotension is going to be observed as well. So this is the poisoning effect of quinine. In the near future, quinine will continue to play a significant role in the management of malaria. However, because of the frequent act stock outs, the rapid withdrawal of quinine as a treatment option for uncomplicated complicated malarial cases is risky. So to summarize everything, we will going to get these points. While the quinine has played an important historical role in organic chemistry, the first stereoselective total synthesis was accomplished by Stock et al. Only 5 years ago. Since the Stock's asymmetric synthesis of quinine, only a handful of alternative synthesis has been published. When you go through net, you may find so many article, research paper for the synthesis of quinine, in which most of them following the classical Robes C8N1 disconnection strategy to build the quinoclidine ring system. In Williams group, the synthesis of 7-hydroxyquinine was accomplished by featuring a C3C4 palladium mediated SN2 type of cyclization reaction to construct the quinoclidine ring system. In addition, the establishment of the C8/C9 stereogenic centers were set by the asymmetric aldol reaction developed in Williams group, while 7-hydroxyquinine was successfully synthesized in Williams group. This quinine analogs was found to be inactive against two strains of Plasmodium falciparum, a parasite that cause malaria. The further application of this innovative approach to the total synthesis of cinchona alkaloid is currently being investigated in Williams group as well. This is further reading you may going to obtain for this. Thank you for paying attention to this lecture. looking for something positive in each day, even if you some days you have to look little harder, and let the challenges make you strong, because difficult roads often leads to a beautiful destination. And I know that you are passing through a very difficult situation in this COVID. I hope you will stay safe and healthy. This much is enough from my end.